Yeah, well, welcome to this channel. We are looking at the Laplace transform, okay, and this is an updated version of the previous lecture, okay. The first thing we want to look into is the symbol. We use this symbol just like L, okay, that's the symbol for Laplace. Okay, then we can also use this one. This is another symbol for Laplace. The next thing, we want to look at the table, Laplace table. I'm going to call it table 7.1, okay? Because I'm going to make reference to that table, okay? We have the function f of t, and then we have the Laplace. This is the symbol for Laplace. You can use this one, which is also equal to what? Your L of what? F of what? F of t. Okay, so this is a symbol. For example, now, number one, the Laplace, the function is 1. So if I want to write this one in Laplace now, just write Laplace of 1. Okay, and anytime you write Laplace, there must be the element of the Laplace, which is x domain. You put it by the side of that function. Okay, so Laplace of 1 is what? Is 1 over x. Then 2, Laplace of exponential. If I want to write this one, it will be Laplace of exponential to power at. Then I will put the x domain as the element of what? Of the Laplace. Just like you have, you are doing an integration, maybe you have the function like this, and you put the x. Same thing also for Laplace. In this case now, this one will just be equal to 1 over then x minus what? The attachment to t. Okay, whereby here s is greater than 0. Here also s is what? Greater than a. The next one is this. Okay, the Laplace of this will give you the power n factorial over x and then n plus 1. We're going to look at a series of questions on this. Then the next one is the Laplace of sine bt. Sine bt. The Laplace of that, if I want to write that, it will be Laplace of sine bt. Then I'll put the x domain by the side. The Laplace of this will be equal to, when you have sine, it will be the attachment to your t, that's a b over s squared plus whatever you have here, then you now square that. Okay? F of t is my function, the Laplace of the function, which is the same thing as what? F of t. The fifth one is a combination of exponential and this one. Okay? So in this case now, it's very simple. It's going to be what you have here, that will be n factorial over x minus this attachment to t, x minus a, okay, then n plus 1. Then the sixth one, Laplace of cos bt. This will be x squared, then plus the attachment to your what? To your t, b squared. Okay? What do we have again? The seventh one, Laplace of exponential with sine bt. It's going to be what you have here, b over x minus the attachment here. You square that, then plus what you have here, you double that, b squared. And then the last one, that will be Laplace of exponential to power at and then cos bt. Is going to be x minus the attachment here, attachment to your t, which is a. Then the same thing you're going to have at the denominator. You double that, you square it, then plus what? Plus what you have here, plus b squared. we are looking at table 7.2, and this we're looking at the properties of Laplace transform. Laplace transform is all about tables. You must be familiar with your tables, which I can call the rules, okay, the formulas, okay. Let's dive in straight to table 7.2, the properties of Laplace transform. The first one we want to look into, when you have the Laplace of sum of functions, okay, you put your domain there, that will be equal to what? Laplace of what? Each of those functions. Laplace of each of those functions. So that's the first one. That's the first one. When you have Laplace of sum of functions, it's going to be what? Laplace of the respective functions. Number two, Laplace of a constant with your functions. Don't forget to put your the x domain. So this is just a constant. So what this properties is saying is that this constant will come outside the Laplace. So you have Laplace of what? F. Okay. The third one is Laplace of exponential f of t. This will be equal to, don't forget your domain here is x domain. Okay, so what this will be equal to Laplace of f of t. Okay, your domain now will now change, so it will be x minus the coefficient of your the attachment to t minus a. Okay, so this property is called translation property. This is called translation properties. Okay. Okay, and the observation is that your domain, your x domain, is now changing to what? To x minus a domain. Your a is a constant. That is the attachment to your what? To your t. Number four, Laplace of first differential, and that will be equal to f of f, then minus f of 0. Then the fifth one, Laplace of second differential is equal to x to power 2, Laplace of f of t, Laplace of f minus x, f of 0, then minus of 0. The sixth one, Laplace of n differential, that will be equal to x power n, Laplace of f minus x to power n minus 1, f of 0 minus x n minus 2, f prime of 0. Finally, omission, the last one, that will be f n minus 1 of 0. But the most important thing is to know the applications. How can we use these properties? And that is what we want to dive in now. We want to look at series of problems, series of questions, and then we'll begin to use what? The tables 7.1 and 7.2. Okay, let's go there.